Hi, my name is Michaela Brohm-Badry and I'm professor for learning and instruction at the University of Trier in Germany. Today I'd like to talk about memory processes and 7 memory boosters. Memory is the basis of learning because without our memory, no learning process would be possible. We would perform the same actions again and again, even if they don't lead to the desired results, like, for example, a car driver who turns off at the same wrong place every day because he cannot remember that this way didn't lead to the destination. The opposite would be, for example, an archer who practices and keeps on developing by remembering. But how does memory work, and what favorable factors support our memory? I would like to explore this in this video. Let's take a look at the agenda. First of all, I'd like to talk about memory and behavior. Secondly, about memory processes, encoding, storage, and retrieval. And then I'd like to talk about 7 memory boosters. Memory and behavior. Memory contracts such actions that we take the wrong turn at the same place every day because it reminds us of what worked or what didn't work in the past. Anything that works out tends to trigger more joy. Dopamine and serotonin are released and cause us to remember the joy and therefore tend to perform the behavior more often. If, on the other hand, the outcome of an action is rather negative for us, serotonin level drops, while cortisol and norepinephrine are overly elevated, a state we want to avoid in the future. We remember the outcome of our actions and align our future behavior with it. In pleasure reinforcement, in failure, we look for other behavior. This is learning. All of these processes rely on our ability to remember. Thus, learning is to a large extent memory work. The place of remembering is the memory, and the process there is divided into 3 parts: encoding, storage, and retrieval. Some scientists also include forgetting in this process. Memory processes. All information is received by us humans through the senses: sight, hearing, touch, taste, and smell. The information thus received is given to the sensory memory. It stores the content for a period of a fraction of a second. Whether with a multitude of impulses or the respective contents are perceived decides whether the content reaches the second storage form, the working memory, with a storage capacity of seconds to a few minutes. Selected contents is consciously perceived here, and encoding and memory lead to the content into long-term memory, where it is stored permanently, sometimes for life. Encoding. When we perceive something through our senses, we store the experience by encoding it, matching the new information with what we already have, classifying it, and changing our existent concepts, as Spielmann explains. However, we do not encode everything we experience, and what has not been encoded cannot be remembered later. Things we seem important enough that we want or need to remember them tend to be encoded more than things we consider irrelevant. Sanjay gives the example of an American cent that people hold in their hands all the time, but can barely describe the appearance. He concludes that we Citation: remember things that are unimportant to us poorly, even if we see them often. 3 types of encoding are distinguished: semantic encoding, which stores words in terms of their meaning; visual encoding, which encodes images; and auditory encoding, which encodes all auditory utterances, such as sounds, tones, and word sounds. For new stimuli, encoding often involves conscious attention and cognitive effort. Gradually, the encoded content becomes automated, making room for new encoding processes such as learning to drive a car. Storage. Once the sensory information has been encoded with sufficient depth, it is stored for possible later retrieval. The process is called storage. A distinction is made in the duration, short-term or long-term memory, the capacity of stores, how much information, and the type of information, auditory, sensory, and so on. Generally, memories are stored simultaneously in different parts of the brain. Explicit memories, so episodic memories for autobiographical events, and semantic memories from general facts and information, are primarily stored in the hippocampus, the neocortex, and the amygdala. By all accounts, the transfer of information from the hippocampus to the neocortex occurs during sleep. Implicit memories, such as motor memories, rely on the basal ganglia and cerebellum. Short-term working memory relies primarily on the prefrontal cortex, as the Queensland Brain Institute mentions. Retrieval refers to remembering sensory encoded storage information, that is, reactivating it from memory. For the retrieval process, the content is processed and reconstructed again in working memory. This means that existing information is not simply accessed, but that known content is reassembled. It is a refabrication process. Thus, retrieval is subject to various influences that can affect memory and shape our memories. Elizabeth Loftus was able to prove, citation, that human memories are often not based on experience events, but, for example, on narratives of other persons, such as other witnesses. Accordingly, these are pseudo-memories. In the case of our memories, both forms of memories are combined at the moment of retrieval of explicit memories. Semantic memories and episode memories complete each other in retrieval. 7 memory boosters, strategies for effective encoding, storage, and retrieval. Neuroscience research has now elaborated basic strategies that promote effective encoding, storage, and retrieval. First of all, make content meaningful and structured. Things are encoded more easily when they have meaning and purpose, as Spearman explains. For example, it is difficult to memorize jumbled strings of numbers. Meaningful strings of numbers or vocabulary in word fields are much easier to learn. Information, facts, and experiences should therefore be stored and retrieved in categories or schemes. Small, meaningful nuggets of learning, chunks, facilitate learning. Secondly, process with all senses. Visual words like car, house, dog are encoded more deeply than abstract words, values, rituals, laws. because concrete objects are encoded semantically and visually at the same time. If encoding occurs at multiple levels simultaneously, encoding deepens and thus increases the subsequent probability of recall. Therefore, if possible, several levels should be involved. Reinforce deep processing by asking questions about meaning. According to research of Craig and Talving, the deepest level of processing of linguistic information is the semantic encoding of language, that is, in the assignment of meaning. What does this word mean? Questions about semantic understanding were confirmed as deeper questions regarding the qualitative nature of encoding. Moreover, it was shown that it was not the length of the encoding period, but the depth of encoding that was crucial for recall, as Craig and Talving found out. Make the connection. What does it have to do with me? In addition, we process information very deep when it has a connection to ourself. This is called the self-reference effect. The self-reference effect describes the tendency, citation, to process and remember self-related information better than other information, as Klaus and Strobel explain. For teaching, this reinforces the high importance of connecting the content to the student's life world for memory formation. If possible, the content should be released to the student's own experience. Repetition has an effect. Repeat the content often. The forgetting curve, first studied by Hermann Ebbinghaus, suggests that recall of learned material flags quickly at first, but that forgetting is reduced by frequent repetition over a longer period of time, and that repetition of previous learned material just before recall shows good effect. Overlearning strengthens. Continue to learn even if you already know. Continuing to learn even when we assume we have already mastered the material also shows good effects. The overlearning strengthens encoding. Sanger therefore advises students to continue learning even if they assume they have already fully mastered the material. And last but not least, learn important things at the beginning and at the end. We remember more easily the information which is positioned at the beginning or at the end of a learning process. This serial position curve describes a curve in which high recall values appear for the former information and the later information. The primacy effect means that the content presented first is better remembered than the presented in the middle of the unit. And the recent effect means that the later content is better remembered than that presented in the middle of the unit, as Rummer explains. So in short, important things should be presented at the beginning and at the end. If we keep these 7 impulses in mind, our memory will boost. Thank you. Thank you very much. Bye.